Hi, welcome back to this channel. In last video, we already discussed about the halogenation of the alkane and also predict the product form, which only focus on the mono substitution of the alkane. So in this video, we will focus on the free radical mono substitution mechanism. Before we continue the mechanism of the free radical substitution, let's look at the tutorial question number 7. Identify the alkane that will give only one product when react with the bromine under sunlight, and then explain your answer. So 2,2-dimethylpropane, let's draw the structure. So propane has 3 carbon, and then there are 2 methyl group at the second carbon. So we complete the structure with the hydrogen. The next one is 2-methylbutane. Butane consists of 4 carbon. Second carbon attached to the methyl group. Then as usual, CH3, CH, CH2 and CH3. Okay, so now here we are going to determine the class of the carbon for the carbon with hydrogen: primary, 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 and primary carbon. So sorry, this one is CH3. So here will be primary carbon, secondary, primary, and also tertiary carbon. So with these two structures, then we know that this alkane 2,2-dimethylpropane will give only one product, and then explain because, okay, the reason is they are equivalent. Okay, sorry, let me erase. Because the reason is it is equivalent. So what is the equivalent means here? Means that they only have primary hydrogen. So any hydrogen replaced will give the same product. However, for the methylbutane, so we will replace the hydrogen, which is the tertiary hydrogen, to get the major product. CH3, CH2, CH3, and this one will be replaced with the Br. So this is the major product. Okay, so for this one, if they want to become the product, will become CH2Br, CH3, CH3, and CH3. Basically, which of the hydrogen is being replaced is no problem. Right. Tutorial question number 5. This is objective question. Identify the compound below which will give monobrominated alkane. Again, is also will give only one product. Okay, mono is referred to one when react with the bromine. So as like just now, cyclopentane, we draw the structure. So all these carbon are secondary carbon, secondary carbon, secondary carbon, secondary carbon, and secondary carbon. While for the methyl cyclobutane, cyclobutane with the square shape and then with a CH3. So here we have primary, we have tertiary, secondary, secondary, and secondary carbon. So this is not equivalent. Okay, this is equivalent. Okay, so 2 will be out. Pentane have 5 carbon, which is with the straight chain 1, 2, 3, 4, 5. So this one is primary, secondary, 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 and primary carbon. So also are not equivalent. Okay, so if they are not equivalent, they will produce mixture of the product. So this one also out. The correct answer is 1 only. Okay, now let's focus on the mechanism of free radical substitution of alkane, at where we focus on the monohalogenation only. So basically, what's the meaning of mechanism? Mechanism, it can be considered is a process. Okay, that we're going to explain how it happened from the beginning until the product is formed. So the free radical substitution, as the name substitution, so you will notice that there is atoms are replaced. And then why there is the term of free radical? Because later the free radical will be formed as the intermediate. So let's, like just now we say that the mechanism means the process. So at here they are going to involve 3 steps. The whole process for the free radical substitution involves 3 steps. Step number 1, chain initiation. From the name initiation, so we know that this is permulaan. Second is chain propagation. In terms that we easier to understand is pembiakan. Then the last step, before the step reaction end, it will end with the chain termination step. Okay, now let's go in detail how the mechanism of free radical substitution. As usual, before we start with the mechanism, we need to have the chemical equation. So from here, the methane, which is the example of alkane, react with the chlorine with the presence of UV to form CH3, Cl, and HCl. So now we start with the mechanism. Step number 1 is chain initiation. So in the presence of the UV, or the heat, the covalent bond in the chlorine molecule will undergo homolytic cleavage to produce free radicals chlorine. Okay, then to keep in mind that as long as we are undergo the free radical substitution, UV is a must. Okay, there must has the UV, the presence of UV, because the chlorine molecule with the formula, with the structure formula like this, which is the non-polar molecule, non-polar bond. So this bond will not break down itself easily. So we need the external energy, which is the UV, to break down the bond. So because of this is non-polar bond, so if the bond is break down, will undergo homolytic cleavage. So at where means that here have one bond, each of the chlorine atom here will get 1 electron. So that's why we need to use half-headed arrow. So how to show this one? Actually, you can write like this, both arrow at the top, or you also can show like what I showed just now. The arrow is at the bottom, or 1 at the top and 1 at the bottom also. Okay, the most important thing is you have to make sure the arrow is come out from the bond. Besides from that, you also need to make sure the type of bond is correct. So which is means not type of bond, type of arrow is correct. Which is the single-headed arrow. Once the free radical is produced, so it will proceed to the step number 2, propagation step. So reminder again, so for the initiation step to happen, the presence of UV is a must. So after we get the free radicals, so from the step 1, so the free radical will proceed to step 2, at where it will react with it will consider like attack the molecule of the CH4 and form another new free radical. So maybe we can do a simple story to say that the free radical chlorine is boring because it haven't achieved octet, so it is alone, have one electron here. So this electron want to be stable, so it need to form a bond with another atom, which means another one also have to share an electron with it. So this chlorine, this free radical chlorine move around and make the CH4. So and then this free radical chlorine say that, hi hydrogen, can you be my friends? And then the hydrogen also say, oh, okay, already feel bold to be friend with the carbon. So that's why the bond between carbon and hydrogen also will be break. Okay, so the hydrogen decide to leave the carbon and form a new bond with the free radical of chlorine. So again, because of this bond is non-polar bond, so the bond will break homolytically. So at where this time we will going to involve to show that, okay, this Cl first arrow showing that the first one electron from the free radical of the chlorine will go and meet with the electron that gained by the hydrogen to form one bond between hydrogen and also the Cl. So it's over here, hydrogen and the Cl. Then the bond here already break, and then the carbon get one electron, so will form as free radical electrons. So and then because of the propagation have the meaning of pembiakan, that means they will be continuous to spread the free radicals. So the methyl free radical will propagate a chain reaction when it reacts with another chlorine to form CH3Cl and free radical chlorine. So now we focus on the next equation or next mechanism. So yes, the free radical from here, okay, is bring to here. This time because like we say that, okay, this free radical lost one friend, which is the hydrogen. So carbon always needs 4 friends. Now only have 3. So the carbon will look for another new friend, which now this time they want to look for the chlorine. So again, the bond between chlorine is non-polar and also homolytic. So the bond will break homolytically again. So this time the bond will form between the carbon and also the chlorine, and then the chlorine will become the free radical. So at where we already get the product that we wish, because in this step we only learn one hydrogen replaced by one chlorine. Then we can proceed to the termination step. Once the major product is formed in the propagation step, then we can proceed to termination step. So in termination step, there are 3 possibilities. Basically, we are consider the free radicals can combine together. So if the free radical of chlorine meet each other, so they will form chlorine. If the free radical of chlorine and methyl met together, so they will become CH3Cl. However, if the methyl free radical met each other, like here and here, so will form CH3CH3. So in simple word to say, chain termination step is a step at where as long as there are 2 free radicals combined to form a molecule, so this step will consider as in the chain termination. So to keep in mind again, the type of arrow that we use always is half-headed arrow like this. Okay, so this side you have to make sure the arrow have to start from the so-called the lone single electron. Okay, to show that these 2 electrons going to meet each other and form a new bond. Tutorial question objective 2. Identify the product in the termination step when cyclopropane react with bromine. So as we know, cyclopropane will look like this. So if one of the bond of the bond between carbon and hydrogen break, so it will form like this. Okay. and then the bromine, it forms free radical, so you will get this. So now we have two species here. Let's label A and B. So as we know in the termination step, any two free radical combined will form a molecule. So we have the possibility A with A. So if this happens, so means that each of them going to share the bond, to share the electron. So we'll form a compound like this. If B with B, so we will get this one. Free radical of bromine and free radical of bromine meet each other, so they will form a bromine molecule. If there is the free radical of cyclopropane with the free radical of bromine, so sorry, don't forget there is positive here, means that they're going to react with each other, so you will have a Br. So these are the three possibilities of the product if the cyclopropane react with the bromine. So from here we can see that the answer is A. Tutorial question number 6. A student add 1 ml of bromine gas into a vessel containing butane at room temperature on a bright sunny day. So this sunny day basically is let us know the UV is present. So when we see here there is alkane, okay, so and then with the UV, so we know that this type of reaction is free radical substitution. So basically among all the homologous series, only alkane will undergo free radical substitution. Write the reaction equation. So we need the equation. So I write the answer over here. Butane have 4 carbon. So you can just write down 4 carbon and then complete with the hydrogen CH2, CH2, CH3. And then react with the bromine with the presence of the UV. So this one is primary, secondary, and primary carbon respectively. So means that this alkane is not equivalent. So there will have more than one product form. So if the primary hydrogen is replaced by the bromine, so it becomes CH2Br, CH2, CH2, and CH3. If the secondary hydrogen is replaced, so the product is CH3, CHBr, CH2, and CH3. And don't forget, the side product is HBr. So for this one here, we no need to balance the equation. Is okay. For organic chemistry, we no need to balance the equation. Is okay. So now proceed to C. Draw and name the major product. So the major product is, as we already know in the tutorial introduction, tertiary free radical is the most stable, followed by secondary and primary, and the least stable is the methyl free radical. So in this case, the one with the secondary carbon, okay, or the bromine replace the secondary hydrogen, will become the major product. So this is the minor product, and the HBr is considered side product. So don't forget, we not just need to draw the major product, we also need to name the major product. So the bromine is at the second carbon, so we call this one as 2-bromobutane. So next question, we are going to write the mechanism, which we will discuss in the next slide. Next one, E. Explain the formation of the major product. So basically, just now we already mentioned. So we have to say that secondary free radical is more stable. So if it is more stable, so it will tend to react with the free radical of bromine to form 2-bromobutane. F. Compare the color of the mixture under the sunlight. Okay, and in the dark, there is two conditions. One is under the sunlight, one is in the dark. So as we know, the color of the bromine is reddish brown. So if put on the sunlight, the reaction is happen. So the bromine will become HBr and replace the hydrogen in the alkane. So under the sunlight, reddish brown of bromine will be decolorized. While in the dark, the reddish brown of bromine remain unchanged. So why this happen? Because in here there is no energy provided to break down bromine bond homolytically. Okay, for the tutorial question number 6, we already finished all the questions except the question D. Write the mechanism for the formation of the major product. So do keep in mind that if the question asks us to write the mechanism, most of the time they need us to give the mechanism which can show the formation of major product. Okay, so if you still remember just now, we already have the idea when the CH3, CH2, CH2, CH3 react with the bromine with the presence of UV, CH3, CHBr, CH2 and CH3 is the major product. Okay, so from here now we will start with the initiation step. As we know, initiation step have to always start from the halogen. So in this case, the halogen is the bromine. So bromine, and then with the presence of the UV will provide the energy to the bromine bond so that the bond will break down homolytically, at where each of the bromine atom will get 1 electron. So again, make sure the arrow is come out from the bond, so then we will have 2 free radical of bromine. So with this, we settle for the initiation step. After we have the free radicals, then we can go to the propagation step. So at this propagation step, the free radicals will attack the butane. So since we know the hydrogen from the second carbon here will be replaced, so we make these 2 4 bonds, CH3, CH, H, and CH2, CH3. To show the bond easier, so maybe you can change the position for this here. Change the position of H with the CH2, CH3. Okay, then now here I put here CH2, CH3, and then here will be the hydrogen. Okay, so we write this structure down here, CH3, CH, and since we already changed the position, so here will be CH2, CH3, and then this one is the hydrogen. And then the free radical from the initiation step will go and attack the hydrogen. So the hydrogen will break the bond with the carbon and bring one electron with it, and then another one electron will belongs to carbon. So when this happens, so we will have CH3, CH, CH2, CH3, because all these three bond will maintain because there is no bond breaking involved the bond. So the bond at the right hand side here already break down, so now only have one electron, and then plus hydrogen bring one electron, bromine also have one electron, so they will form one bond in between hydrogen and Br. Okay, this is the first step of the propagation that we write in the previous slide. Okay, propagation step. Okay, so now we're going to continue the mechanism with this free radical. Okay, so this free radical now CH3, CH, CH2, CH3 with the free radical, and then must be react with a molecule. So because we need to form a haloalkane, so this time the free radical of the alkane will going to attack the bromine. So once attack the bromine, same case with the previous step, the bond between the bromine molecule will be break down homolytically, and each of them get one electron. So with this, so the product will be CH3, CH, CH2, CH3, and here we'll bonded to the Br with the free radical. So from here, our major product is produced. So if you redraw this structure, actually it is still similar with the one that you write in the chemical equation. Okay, CH3, CH. So now if let's say the position of CH2, CH3 and Br replace, so here will be Br and then CH2, CH3. So with the major product is formed, then we can proceed to we already finished the propagation step, and we can proceed to the termination step. Okay, we are near to the end of the mechanism. Now we proceed to the termination step. So as we know, termination step will involve combination of two free radicals. So before we proceed to here, then you can recall back to the propagation step. Just now we have this free radical, CH3, H, CH2, CH3 free radical, and then another free radical is bromine free radical. Means that we have two types of free radical here. So free radical A and free radical B. So there are three possibilities of the combination: A with A, B with B, and A with B. Okay, so now we can start with the first one, CH3, CH, CH2, CH3 with a free radical, and then plus free radical CH, CH2, CH3, and then CH3. So in this case means that I change the position of this CH3 and the free radical here. Why I do like this? Because I want to show the bond formation of the electron, the combination of the electron and form a bond easier. So from here, then I will write down here. Okay, so this electron will bring this carbon will bring its electron, and then this carbon also will bring its electron, and then they will meet together. Okay, so here we have not enough space, so I erase this part. Okay, then end up we will have the product CH3, CH, CH2, CH3. Then just like draw a line. So because we connected the two electrons to form one bond. So CH, CH2, CH3, and here is the CH3. So beside A and A, we have B with B. Okay, so if B with B also same, the arrow come out from the electron and then will produce bromine. So next one is the CH3, CH, CH2, CH3 free radical plus free radical of bromine. So both electrons meet together and then end up will form CH3, CH, CH2, CH3, and the two dots connected to form one bond which bonded to the bromine. So we already end the part for the mechanism of free radical substitution for the bromination of butane. So we will end the video here. So more questions will be discussed during the tutorial time. Thank you for your time and see you in the tutorial. Bye.